A microphone for you guys feels a little bit overkill, doesn't it? But it's nice you've stayed around to the end. Thank you very much. So I'm Rick Harvey. I'm a technical developer evangelist at AWS. My region is UK and Ireland. So if you go to any of the meetup groups, you'll see me about occasionally. If you're not in the meetup groups, highly recommend you join one. Go to meetup.com. Look for the Dublin user group, and you can come and join. It's one of the biggest in the UK and Ireland, and it's probably the most professionally run, so it's really good. Meetups take place at the Button Factory. You can go and talk if you want, if you've got a cool use case to talk about, and it's about peer-to-peer sharing of knowledge. So it's like this. Sometimes we're there, sometimes it's other customers all sharing their knowledge, so highly recommend doing it. So a little bit about me. My background, I was a Linux admin and a solutions architect. Like I say, focused on Linux systems. Used to build very high scale websites, so databases is a key part of that. I worked at Ticketmaster and I worked for Channel 4 Television. Both had huge database requirements behind, so at least I can bring that bit to this talk and talk about how we used to do things and how some of the services on AWS has made it significantly easier. So I'm going to talk to you first of all, and I'm going to talk to you about Amazon RDS. RDS is Relational Database Service. It's a often single or three-click deployment of many engines for databases. I'm going to talk about Aurora in a minute. I always put that to one side. We've got Postgres, MySQL, and MariaDB on the open source offering side. And you can choose to deploy these as a single availability zone or in multiple availability zones for high availability. So anyone not familiar with AWS, a region is a geographical location, and then an availability zone, the best way to think about it is a separate data center. So different power, different internet connection, different networking. It's all separate, different cooling. For one of those buildings to fail would be quite big. For two to fail, it'd be very, very rare. For the whole region to go offline, it's never happened. So fingers crossed and touch wood. So if you deploy multi-AZ, you get 3 versions of your data in RDS. I'll talk about Aurora in a minute. The data is replicated from one availability zone to another very, very quickly, and it's because of some of the optimizations we've done under the hood. And then we've got commercial offerings, Oracle and SQL Server. In these cases, you can either bring your own license, if you've got the right type of license, be careful about that, or you can pay per hour for a license on these databases as well. It's very, very easy to provision and switch these databases on. I still remember the days of like ordering kit in and having to put the memory and the disks in myself in servers, and then as you rack and stack them, you used to cut yourself on the racks and give a blood sacrifice to the database gods. Those days have gone. It's just a simple click deploy now. You can also scale it relatively easy. If you're running a multi-availability zone deployment and you say, I need a bigger instance behind this, I need more RAM, I need more CPU, you can simply go in, edit, click deploy. And what happens is it'll take one of the servers that's waiting to become master, one of the slaves down, it'll replace that first with a bigger instance, and then it'll do an internal failover, and that'll be promoted to master, and then the other 2 instances will get replaced. So it's a very, very small amount of downtime and just a blip in your app, really, to handle that kind of upgrade. Why would you use RDS rather than doing it yourself? Has anyone ever built a database themselves on AWS? No, don't. I have, in the days before RDS existed. So if you're doing it yourself, you've got quite a lot of things to manage. You bring up an EC2 instance, you've got to install the operating system and maintain that with security updates. You've got to maintain the software stack as well. Let's talk MySQL. You've then got the disk where your data's being saved. So you've got to manage backups of that and snapshots. And you can't just snapshot a disk with a running database. You've got to lock the database, flush the database to disk, and then take a snapshot to get a clean version of the data. Otherwise, you're going to have corrupt tables if you just try and bring it up. And that's in one availability zone. You then got to say, oh, actually, I need this data highly available, so I'm going to put it in 3 availability zones. And at that point, you've trebled your costs and storage. You've trebled your disk management, your OS patching. You've got quite a lot of things to do. Many, many years ago, I built a MySQL highly available cluster on-prem. This was before cloud computing existed. And we had 12 servers, 5 markets. Each market had 2 servers, and it was cyclic replication in MySQL. This was before Galleria had come out as a decent clustering option. And then we had load balancers sat in front of that to send connections to the right place. You used to have to do things like index offsetting, so one server could do odd auto-indexing, one server could do even auto-indexing, otherwise you ended up with clashes. Then we had a big NetApp filer behind it to handle the data and the snapshots. And then we had to build a control plane on top. There's a lot of work in doing something like that. It's doable, but there's a lot of work in doing that, and it's expensive. And NetApp isn't cheap, NetScalers aren't cheap, and you've got to double up on everything so you've got high availability. And then you've got to host it somewhere. RDS, you get that without doing that work. You just click and deploy, and we're doing that heavy lifting for you behind. We've built the control plane. We're looking after the storage tiers. We're looking after the servers. If one fails, we replace it. Most of the time, you'll never know. If there is a failure of a master server, there's a very, very, very low TTL, time to live, on the DNS record that points into your endpoint, which is your database. So that gets replaced very, very quickly. And most web applications will be perfectly fine with a minor blip in connectivity to MySQL. So most survive this. Which should you use? I would say stick in this side because it's going to be a lower cost of ownership. These are open source. Huge fan of open source, and your costs are lower. I think Steve, in the State of the Union, if he was here for that, he probably talked about migrating and the migration tools that you can get. So we've got a database migration service. So if you've got on-prem versions of these, it'll actually do automatic schema conversions, and Oracle normally maps over to Postgres quite nicely. It's got a lot of the same features. So you can do automatic migrations from Oracle over to Postgres, worth looking at. And then this one, which I said I was going to leave for a little bit. I'm going to talk about it now. Amazon Aurora. What is Aurora? Is it your own database? Well, yes, but it's fully compatible with both MySQL and Postgres. What's different about it? Well, we're going to talk a bit deeper on it in a second, but it's basically the storage layer. With Aurora, you also get 6 versions of the servers running, 2 in each availability zone. And this gives it a lot quicker failover if there's a problem. And we're talking sub-second now. So if one of the masters fails and it's the active master, sub-second, it'll be replaced with the other one in that availability zone that works. If an availability zone fails, we go to another availability zone. The storage layer underneath, we've completely rewritten how replication works. So on both this and this, you'll notice that you can't use the super user in MySQL, for example. And I can't remember what it is in SQL Server. It's an SA user or something like that. Have we got any SQL Server people here? SA user or something like that? Yeah, that's disabled. And it's by design because we're doing a different type of replication underneath. We found that, particularly with MySQL and SQL Server, the replication and the binary logs being chucked around the network and things catching up isn't particularly efficient. So starting with RDS, we started doing block level replication. When it came to build Aurora, we built a storage system from the ground up. So we rebuilt this storage tier, and data stored in much smaller chunks, and it's stored in chunklets that's spread out across the file systems. It's super fast to replicate, and it makes recovery very, very quick. It means the data's always available everywhere. It's wonderful. It's really quite cool engineering that they've built. Now, I've said they're both MySQL and Postgres compatible, so there's 2 flavors of Aurora. The nice bit is that if you decide that AWS is no longer for you, and you want to go back on-prem, or you want to move it to another cloud provider, you've not been locked in by this. Even though it's got the Amazon branding over the top, you can do a MySQL dump. You can pull your data out and put it back in a standard MySQL server that's running anywhere in the world. So you're not locked in, you're not forced into that method. You've got pure compatibility and freedom of movement. So which instance type should I use? So after reInvent, there's some new models of these anyway. After reInvent, there's R5s, and we've got M5s as well, which have come out. Normally, the difference between M3, M4, and M5 is the actual processor inside. So the M5s are the Skylake processors from Intel. And if you look at those, they use a lot less power. Because they use a lot less power, they're cheaper for us to run. Because they're cheaper for us to run, they're cheaper for you to rent. We pass that saving on. So there's economy of scale there. So that's normally the good reason for like moving up a level. Now, if you've got a small personal blog, I'd say use a T2. You're not going to have huge data putting through your database. It's not going to be heavy CPU usage. You're not going to need a lot of RAM. Small database, personal blog. Your family might look at it and some of your friends. Now, if you're doing something that's WordPress, it's still a blog site, but it's for a business, that's when you start considering the general purpose instances. Now, the T2s have burstable capacity on network and I/O access. So you have a bucket full of credits, basically, and you can go above and beyond what resources you're initially allocated, which are smaller than the M's normally. But once that's happened, you'll get capped back down to the limit that you've picked as a T2. So T2 small or medium, for example. The M's aren't burstable. You basically pay for what you ask for, so they're more expensive. And then the R-class family, these are memory-heavy instances. So there are, why R stands for memory? I don't know. Anybody know? I don't. RAM. Hey, I never thought of that. Well done. I've learned something today. So yeah, RAM heavy. I'm gonna use that from now. Thank you. RAM heavy instances. So up to 64 gig of RAM, and up to 488 gig of RAM on there on the CPUs. We've got higher performance networking and access into things like EBS for optimized EBS connections as well. So very intensive workloads, huge databases. That's what you put on these things here. Now, when you come to launch an RDS instance, how do you do this? If you're using the open source flavors, you don't really have to worry about this first one, optimizing license costs. If you're using other products, so Oracle or SQL Server, there's a license per core often on those, and it can get quite expensive. So that also might affect which instance type you pick. You might not want 8 cores because your license might only be for 2. So you'll end up getting in trouble with one of those providers. And they do audits. And then you've got things like threads, and can you disable them, or you're going to do something like hyper-threading, and if you're doing high-performance computing, you probably want to disable that, because it's all about throughput rather than the processing on there. When you create your database, it's quite easy, and You can actually move between instance types as well, so you're not locked in. Like I said, you can upgrade or downgrade the instance size, and if you're multi-AZ, it's relatively simple and relatively painless. If you've got a single availability zone one, say you're doing some kind of dev environment and you've just got one MySQL server, or you're doing it for cost optimization, but you decide you need a bigger instance, what you can do is take a snapshot of your database, and then you can say, I'm going to restore that from a snapshot. And it basically creates a brand new cluster with that data snapshotted on, and then you terminate your old one. You get a new endpoint to connect to, but you've replaced it. And it's relatively quick and relatively pain-free, so it's pretty simple to do. It's not like the old days of copying data around and rebuilding servers, so that's good. And we've now got this restored database instances to a point in time. This is pretty cool. So if you're doing some work on prod, like we all have in the past, what could possibly go wrong? And you go and toast a table in your database, and you think, if only I could go back 6 minutes in time. Aurora now supports this, so you can roll back 6 minutes in time. As long as you've got that feature switched on, roll back 6 minutes in time and start breathing again and relax, because everything's going to be all right. So there is a point-in-time restore now, which is pretty cool. I can think of several occasions in the past as an admin where I wish I'd have had that feature. Who here has toasted a database before? Go on, hands up. Yes. It's a sharing circle, we can all be honest. So another thing, and I'm going to tell you a little trick here. I don't ever use magnetic disks. I find them too slow. Most things, when you start them up these days, come with these general purpose disks. These are SSDs. And depending on the size of the disk you deploy, depends on how many IOPS you get. So how many operations per second you can have. And if you've got a really work-intensive, read-write intensive database where you're writing to the disk lots, you might think, oh, performance is struggling. So I'm going to do provisioned IOPS, these IO1 disks. Sometimes, and you have to put this through the simple calculator, the AWS simple calculator, it's cheaper to say, my database is 8 gig, I know it's not going to grow, so I'm going to have a 10 gig disk. If you put it on a 10 gig disk here, you'll get a certain amount of IOPS. If it's not fast enough, you might consider upgrading to a 10 gig disk with provisioned IOPS. Sometimes you can get the performance you need by saying, actually, I'm going to put this on a 100 gig disk instead. And yeah, there's a lot of wasted space, but you get a bigger bucket of IOPS for that disk. And it might be enough capacity and cheaper than going for a 10 gig provisioned IOPS. So that's a little tip. Have a look around. It's not always just click upgrade to the next. Have a bigger disk. It will potentially save you a lot of money. So have a look at that. Now, where are we going here? How do you decide? It's about cash. IO1s are not the cheapest of disks. You can sometimes do it with a bigger disk. So how do you scale your database instances? There's so many ways now, it's unbelievable. You can scale your disks, and we now support the elastic disk resizing, which is pretty cool. Yet again, a feature that when I started with AWS and using it, I'd have loved to be able to say, right, this EBS volume, it was 10 gig, but now make it 50, instead of copying data back and forward. It's now supported in RDS, so you can grow a disk, which is really cool. There's different ways to scale. It's not just about instance size. And I'm going to try and cover some of those in the next section. So let's first of all just go and have a look at a bit of an app. And one of my colleagues wrote this app, and I think he was feeling particularly in a dark mood this day because all the icons are black and look very satanic there. But a typical website here. We've got a load balancer coming into multiple web servers. We've got some application servers doing some churn at the back, and they're talking to our database server. Now, in this particular example, one of our database servers has failed, and it's being replaced by a standby. That standby stays hot, and if this was to fail, we'd flick the DNS resolution over onto that standby very, very quickly. And that gives you automatic failover. It's replicated between there. It's brilliant. And it's inexpensive, and it's enabled with one click. It's cheaper than doing it yourself. If you're going to build 3 EC2 instances, not only through management time, but through cost, it's actually cheaper to do it this way, multi-AZ. During this failover, the DNS is basically getting changed. We remap your app using DNS to the second EC2 instance, and we do that at a very, very low TTL. There's some algorithms going on in the background that's achieving quorum between all the databases and the data, and then we just redirect the DNS. It's super quick failover. Now, one way to scale your database is to decide whether it's read or write heavy. And by this, I mean, let's say you've got a news site. This is the best example I can get. You've got a news website, and you've got 30 editors or 30 journalists creating articles. But you've got 20,000 people visiting your website, 20,000 customers. You've got 30 people writing, but 20,000 people reading. So you're going to have a read-heavy database. Every time someone hits a page, it's pulling data out of the database. There's multiple strategies to cope with this. You can do different levels of caching with things like Elasticache and Memcache. But it might be that you want really fresh data all the time. You want to be finger on the pulse, up-to-date news, the latest articles, always there. And that's where read replicas can help. Read replicas can't take write commands, but if you work on your application logic, you can actually split reads and writes. So when your journalists log in, they send all their write commands to the master server, and everybody else who's reading pulls data from the read servers, and it's fanned out, it's spread, the load's spread, the data's there within very small amounts of time. It's replicated out to everyone, and you can get back. The only problem is if you're not careful in your application logic there, you can end up with situations where a journalist is doing a write and then trying to do an immediate read of that data. And if you've not split the application logic correctly to send all their commands to the master server, you might do a write, try and do a read, and you'll get a database error because that record hasn't been found because it's not replicated down your replication stack yet. Propagation. So this is supported with MySQL, MariaDB, and Postgres. In the open source versions and in the Aurora version, you can add read replicas very easily as well. And yet again, this is kind of like a really easy click deploy. And in the RDS section, you can actually say, okay, my master database has now failed. I'm going to pick one of my read replicas and promote it to master. So you can do things like that as well, which is kind of cool. And that works across region. You can have read replicas in other regions that you can promote to be in the master. And that means your data exists in more than one geographic location. Your high availability has just gone to the next level, which is pretty cool. So why would you use a read replica over multi-AZ, or why would you use both? So highly durable, very quick failover times, backups to be taken. Have I mentioned backups yet? So backups are done automatically in RDS. This is the best thing ever. As an admin, I used to hate taking database backups. No, I used to hate restoring database backups because I never had enough time in the day to go and check if that database backup actually worked. Imagine doing that every day when you're backing up your database 4 or 5 times. So when it came to doing it in anger, there was always that innate fear that this database isn't coming back. You're going to get some errors in. The way we've done the storage layer underneath has lent itself to taking very, very quick, as in seconds, snapshots of your database. We'll flush it to disk, we'll snapshot it, and it'll be stored in EBS snapshots. And then you can restore from it whenever you need to. Lifecycle management is also in that. It will do lifecycle management, and it will do deletion of old snapshots. Encryption at rest as well is also built in. You don't have to do it yourself anymore. And it's like, woo, love it. So these are some of the reasons for using multi-AZ and read replicas. Read replicas can be cross-region, and that's the important thing. So if you've got a global customer base, and they're a read-heavy global customer base, read replicas to another region reduces their latency of their web app fetching that data. So they'll get a faster experience in your web application, and they'll be happier customers. Right. I've got a backup slide. I forgot I got a backup slide. So EBS snapshots are actually stored in S3. You'll never see it in your S3 bucket, but that's how they're stored. Like I say, you can switch on encryption with this as well, and that's managed through KMS, or you can use Cloud HSM as well. So they're pretty easy to do. Automated backups versus manual. So automated backups, you set a retention period, and you also set up a backup window. So this is the time when your database might go offline for a few seconds while it's being quiesced to disk and then snapshotted. So you set that up, and you pick a time when your website's not busy, and snapshots happen automatically in the cycle. However, if you're going to do like a big schema update, or you're going to push data in, or you're going to do something that's updating your app, that's when you choose to do manual backups. And you can do it in the console, or you can do it via the command line. There's also, all the SDKs have got support for this as well. So if you're writing Python or Node, or however you're automating your infrastructure, you can do it through this way. There's a maximum of 35 days when you shut automated backups down, and we'll keep a backup for that. But if you've done automated backups and you've tagged and you say you want to keep longer, there will be. You have to delete these yourself. So if you're doing lots and lots of manual backups, you've got to think about managing your costs of storage. That's one thing to definitely consider. These support point-in-time backups. These are just a snapshot at a certain time. You can't go back several minutes. It's really weird noise coming from over there now. Brilliant for disaster recovery. This is deleting databases, updating databases, making a significant change to your data structure. Taking backups is super, super easy. On the console, you basically go in, you set your time. So here we're saying, take a custom snapshot at this time. And when you launch a database, you can actually pick the snapshot you want to restore from. So restoring it is just as easy. You say, this snapshot on this day, right, create me a brand new database instance with that data in it. So really, really easy to do. And it saved my life several times as an admin. It's like, oh, it's there. And I know it's going to work. That's the best bit. I know that data is coming back. These are tried and tested, and obviously we've got hundreds of thousands of customers on RDS, and it always works. So securing data. When you create a database instance, there's some cool features here now. So you can actually control authorization into your MySQL and your Postgres. I think Postgres is in beta, via IAM. So you've already got credentials to log into AWS. You can actually use those credentials to authenticate you with MySQL. And that even goes further. So in your web applications, you're used to going in and you're used to hard coding MySQL endpoints and passwords in there, and usernames. Usernames and passwords you can forget. You can grant that IAM access on a role base, so the instance is allowed to access MySQL and authentication happens automatically for you, which is pretty awesome. When you spin up a database as well, you get the chance to make it a public-facing database, at which point your security groups are very, very important to who can access. Don't put a 0/0/0 rule on there, because anybody can try and connect to your database and brute force your password. Or you can have it private, which means it's not routable from the internet, It's not got a public IP address. It's got a private IP address inside your virtual private cloud, your network. And if you're doing that, I highly recommend that when you set your subnets up, you have 3 public subnets, 1 in each availability zone, 3 private subnets, which is where you run your web servers, and then load balancers go in public. And then you have 3 subnets for databases, and you keep your databases there. And then that means if you bring up any other application servers in the private, you've got not only network access control lists you can use to control the access between the subnets, the security groups as well. So you've got a double bastion security layer there for your databases. So I highly recommend that. And SSL connectivity into those databases as well. VPC, like I said, it wraps it inside. It means you can access your data. If you want to access your database from the office, you'll probably want to put a VPN connection in. You could even put it in its own VPC and use VPC peering to connect into the database. And 2 weeks ago at reInvent, we announced Transit Gateway, which is a new way of connecting all your connections and VPCs and cross-account VPCs together and doing some really cool stuff with the routing. You can get down to a proper network level and say where traffic can go and can't go. So there's lots of ways of doing this. Access to databases, like I mentioned, you've got IAM access for credentials in there now. That's pretty cool because it means I don't have to use a secrets manager to hold those database connection passwords, or even worse, I don't have to hard code those passwords into my code that I might store on GitHub that I might accidentally make public, and then anybody can get to my database if it's on a public endpoint. So it's really good that you don't have to do any of that anymore. Encrypting databases. So there's actually a webinar that you can look up that talks about different encryption processes of how KMS works. From a very high level view, you have a master key. When you request to encrypt some data, what it will do for that particular encryption request, it will generate another key. That key is then encrypted and stored with the data. And the data is encrypted by that key. So in order to get the data unencrypted, you need access to this, which you can control by IAM, which your users can access those keys. And that will first unencrypt that key, and then that key will come and unencrypt your database. So when you're storing data at rest, when you're taking your snapshots, you can have it all encrypted, nice and safe, which is pretty awesome. Monitoring. The monitoring dashboard for RDS is pretty awesome. You dig into CloudWatch, and in CloudWatch you've got a ton of logs that come out, but also you've got these dashboards that are pre-created. You can see your CPU, RAM, network I/O, slow queries, and dig into what's actually causing delays in your database if you've got a slow performing database. So pretty awesome. Can we know when service events happen? Yes. There you go, I've answered it for you. So this is one of the features that is pretty exciting. On data change and triggers, you can have a CloudWatch event happen. When a CloudWatch event happens, you can trigger something like a Lambda. So if somebody changes a particular field in your database and it triggers a CloudWatch event, you can have a Lambda trigger. So it might be there's a new file created, that means a new customer's signed up, and part of my job is then to pull that data out and send it to a printer and send them a welcome letter or an email or something like that. You can automate your job. So when somebody new signs up, something gets put in the database, do this job by emitting events. And that's pretty powerful. It really changes how you build your workflow in applications. You don't have to sit there polling your database all the time. You can have these events emitted. Maintenance-wise, so I've talked about backups and how they're automatic. Maintenance is also automatic. You set a schedule for when we can go and do minor updates to databases, and in the night we'll go and do minor updates. However, underneath, we'll also be doing operating system updates. So if there's a libSSL problem, we'll be fixing that for you. And that's transparent. You won't see any of that happen. There's nothing for you to do. It just happens. And it's super quick as well, because yet again, we take that storage layer, we basically replace that instance with a new one that's patched, and we flick it over on the DNS after it's been connected to that storage layer. So it's really, really fast. We do it for you. If you've got a database that is getting towards end of support because there's security issues with it, we'll keep notifying you. And we'll keep telling you, I think it's, if there's a version dependency going, I think, what's it down here, 3 to 6 months before the scheduled upgrade, we'll be in touch. And if you've not responded or clicked accept on there or gone and done the upgrade yourself so you can sit there and watch it happen, you'll get a call. We'll ring you up and say, you've got a database that needs to be replaced for security reasons, and we'll talk to you about it and help you through that process. So there's 750 free hours on a T2 micro, so if it's a personal blog, that's like running a database for free, basically every month. So you get, you charge for storage, that's one thing, and you charge for snapshots. So that's why maintaining your snapshots automatically on a lifecycle manager is quite important. Lifecycle manager didn't used to be in the product, and you could end up with thousands of database snapshots. And you go, why has my bill got so big? That's all been taken care of now, and it's all dropped down. So how can you save money? Reserved instances, like you can for EC2, where you can pre-purchase instance capacity for a year or 3 years ahead. You can do the same with RDS and save money on there. 33% saving, I think, is one of the figures. You can also bring your own license. So if you've got a flexible license agreement for Oracle or MySQL, you can bring those, and then there's a lesser charge on the running of the RDS instance. Can you stop your databases when they're not in use? Yes. You can have them shut down and automate this process as well. You can stop them manually. You can automate it by using other features, Lambda or Systems Manager, and it's pretty cool. So if you've got a dev environment, you can stop it. So let's talk Aurora now. Aurora is RDS on steroids. It is super, super fast. It's designed to scale out. All the admin tasks are fully managed for you. It's got its own unique shared storage system that's been written from the ground up. Lots of SSDs underneath that are aggregated into this storage layer. Things are stored as datalets that's moved around. And it exists in 3 availability zones from the start. There's 6 copies of your data, actually. There's 6 running servers at any time on an Aurora cluster. 5 times more throughput than RDS MySQL, and 3 times more throughput than Postgres RDS SQL. And that's purely because of that custom storage layer that we've written underneath. That storage layer also leads to really, really fast recovery times. So while I've said seconds for RDS, Aurora is milliseconds. So if your data is critical and you can't go down for seconds, this is super fast recovery times. The performance, read-write performance, just blows anything else away. And RDS is even better than if you do it yourself on EC2. So you've got to think about these as like next level. How did we achieve this? Well, we rewrote some of the engines. MySQL is quite a chatty engine, for example. Does lots of I/O operations on disks. We rewrote, we re-optimized that engine, built our own engine up on there. Packet sizes. If you've ever done any like really high throughput MySQL building in the systems behind it before, doing things like jumbo packets on networks used to be a thing where you had to make sure you could send large payloads of data just to keep up with speeds, and not using things like NFS, which didn't like that many systems. But then what did you do for shared storage, and how did you back it up? It was a hard work. We've optimized all that. We've taken it away. You don't have to think about it, which is wonderful. If only I was 20 years younger. it would be a lot better experience of building some of these systems. So here's a bit of a difference between how replication's handled with RDS versus Aurora. Aurora has these virtual distillers basically floating about. It's backed by S3 and the disks for an algorithm that basically ensures quorum and the data is always in sync. If one of them fails quorum, I think you can lose up to 2 and you can still have quorum achieved. So you could lose an entire availability zone and the data would still be kept in sync with no performance degradation at all. Performance enhancements, so smart selector. So this is a way of sending data not just to the master server. We've also done some things with multi-master. Have I got that on here? I don't know. We've now got a multi-master version of Aurora and a global multi-master version of Aurora is in preview. So you basically got a global database where you've got local endpoints in different regions. And if you've seen any of the talks about the fiber network we've got between regions now, the only thing that's slowing down the replication between regions is the speed of light. We can't send data any faster at the moment. Maybe a bit of quantum in there, and we might be able to get some data like appearing before you've even put it in your database. You never know. Schrodinger's cat and all that. Availability. 6-way replication in Aurora, so twice as much already as when you talk about RDS. So the failover in an AZ is hyper quick, really, really quick. When you lose a zone, if you lose a zone, I don't say when, it's never happened to me, touch wood. The data is still available here, and then there's a higher level DNS TTL that flicks it over. So that's all like linked into Route 53, and it's all automatically handled for you. This, what I'd given for this when I first started my career. I remember, has anyone ever restored a database from a backup that's gigs big? How long did it take?
Previously, multiples of hours.
Yeah, multiples of hours. Sort of like you set it going in the morning, you think, I'm going to go out for lunch now. You come back, it's still going. You're then thinking it's a late night, and then you think, I'm going to get up in the morning and it'll be back. I remember.
New disks now you can get a 1.2 terabyte database in less than an hour.
That's good. I did a 90 terabyte restore once. It took nearly 3 days. We're talking a long time ago, but that was on NetApps, and they were fast. They were the fast storage, but it took days. The restore on this, super, super fast. 30 gigabyte database in 123 seconds. I'll take that, please. Absolutely. So, there's a few more clicks on here. And this is with Postgres as well. Crash recovery times, super fast. Now, you can have, in the region where you're running the Aurora master, you can have 15 read replicas. And if you go multi-region read replicas, in each other region you can have 16 read replicas running because you've not got that one taken up by the master Aurora instance. Read replicas, yet again, you design your application sensibly, you use fan-out patterns, and you send reads to one set of servers, writes to another. Less than 10 milliseconds for replication going through there. And you can auto-scale it. So there's metrics that come out of here, and you can say, okay, I'm hitting a certain threshold of connections, and now want to add more read replicas automatically, and all that connection's gone down, I'm going to shrink that down. So you can auto-scale those read replicas as well. Cross-region, like I said, up to 16 cross-region. It's brilliant for bringing your data closer to your end users, faster response time for them. And if a region was to fail, you can promote that region to being a master region, and you can recover. So disaster recovery is really, really cool on that. So we say now on Aurora that there's 0 down patching time. So you don't set that window. We patch, we do it underneath. There's some cool cool internal tools, which I can't talk about, that do all this job. But put it in context, we had an engineer who once worked out how to do some patching virtually before, like, you could do like V-splicing on kernels to patch a live running EC2 instance to put in hypervisor changes that was having to do on the system underneath that he'd also worked out to do while live. So there's some very, very intelligent people who write this stuff, and I was super impressed, and it was way above my head how he did it, but similar sort of resources are put into doing this for here. You can also clone Aurora databases very quickly because of that super fast, efficient storage layer as well. And point-in-time releases, point-in-time restores from the database is possible in Aurora as well. Like I said, you can rewind, you can go back 6 minutes if you've just toasted your database and not have to say, ring your boss up and say, I've lost a day's worth of transactions because we've got to restore to last night's backup. So that's a wonderful thing to have. Get the same sort of performance insights built in by default on here. You can dig in, you can see slow queries and all that kind of information that you're used to if you run your own database server. But it's just wrapped up in a nice dashboard. You can actually click and expand these and see what was going on in there and dig deeper and get more information. We get 35 days of data retention. And you can adjust the time frame of when these logs come through and are analysed as well. Fast database cloning. This is done by the super fast storage layer that I was telling you about. It's quite cool. Now, there's one thing that gets me about this is if you wanted to clone your database from production to dev or stage, I would always say just be careful about what you're doing there. Generally, any organization doesn't take as much care over the front-end apps that's a dev or a stage app, and it might not be patched as much. And if you're just cloning your database like for like, think about the data that's in there. Is it personal identifiable information? I would always recommend, if you're going to clone a database, make sure you do some kind of process on it after and do some anonymization of that data that's in there. Make sure it's live-ish data, but just think about that personal identifiable information. That's just from my security hat on there. So always think about how you do that. Here's our clone from dev to test. It's in minutes. It's also good for if you've had a security breach, you can clone the database, put it into an environment where you can go and do some forensic analysis on it, and you can spin up a clean copy of that database from a restore. So it's kind of useful as well. That's how there's a lot of ways to scale databases. Read replicas, multi-region, read-write masters. There's lots of ways to do it. Changing instance sizes. RDS makes it very easy. Aurora makes it even easier. Plus, you probably don't need to upgrade Aurora because you've got that performance boost anyway. So I hope that's shown you some insights into which one you might choose to pick. I'd always say never be worried about being locked in with Aurora because you can just dump your database and move away. But you get this brilliant performance increase anyway, so it's really worth doing. Aurora is our fastest growing product, still the fastest growing service that we've got on AWS. And it's used by some very big companies, so it's well tested. There's certain parts of Amazon Retail that use it. We use DynamoDB heavily as well in Amazon Retail. But all of these are hardened and battle tested by some of the largest sites in the world, so really good to use. Thank you very much. Cheers.